All right, so this one, it's not about factoring. It's about solving equations with a different method. Not by factoring, but by taking square roots. So, you know, the standard form quadratic equation is ax squared plus bx plus c equals 0. Right? We know what the a, b, and c represent. Okay, if b equals 0, then you don't have an x term. You have an x squared term, but you don't have an x term. So remember, when we were solving with all three terms in the quadratic expression, there was no way to isolate x because it was in two different terms and they weren't like terms. But if you don't have the middle term, well, now you can isolate the x. Right? We don't have the same issue. So if that's what you've got, if you've only got the squared term and a constant term, isolate the squared, right? Isolate the x squared, and then take the square root of both sides. But remember, when you take a square root, you have to include plus or minus, right? Because, you know, the square root of 4 is 2, but you know, negative 2 times a negative 2 is also 4. So when you take a square root, you always have to include plus or minus. You know, and just so there's no confusion, because, you know, this gets a little complicated, but when you've dealt with radicals in the past, you know, if you have in a problem, they say, what is the square root of 4, right? When they give you a radical like that, they assume you want the positive principal answer. So that's not plus or minus. But when you are taking the square root to solve an equation, you need plus or minus. Okay, so you assume a square root is positive, but when you take the square root, you got to include plus or minus. Okay. So let's practice those 3 steps here. So the first step would be isolate the x squared. Okay, well, what am I going to do first? I mean, there's a 3 and there's a 5, right, that I got to get rid of. Which one am I going to get rid of first? The 5, right? So subtract 5 from both sides. So now we've got 3x squared equals 36. Okay, then what? Divide by 3. X squared equals 12. Okay, so we've isolated the x squared. What is the next step? Take the square root of both sides, right? So the square root of x squared equals the square root of 12, right? So x equals, now we're going to have to include plus or minus. Plus or minus means it's both the positive and the negative answers, right? It's a way to kind of write them condensed. But the square root of 12, what you don't do is turn it into a decimal. You have to simplify it without turning it into a decimal. So you have to think, is 12 a perfect square? Does it have any factors that are perfect squares? Which is the factor of 12, which is a perfect square? 4, right? So you can write it as the square root of 4 times the square root of 3. And then the square root of 4 is 2. So it's 2 times the square root of 3. So x equals plus or minus 2 times the square root of 3. So don't turn them into decimals. Right? We're expected to be able to deal with radicals without turning them into decimals. But what that does bring up is that we need to review a little bit about radicals. I mean, you did all this stuff in Algebra 1, but you know, we actually do quite a bit of it in this class too. So I don't know whether they really think that you've mastered it yet or not. But there's a couple properties that we use. We just use the first one, product property. Right? If you have the square root of a product, AB, equals the square root of A times the square root of B. It means you can split them up into different radicals. And that's exactly what I did on the last slide, right? I split up the square root of 12 to the square root of 4 times the square root of 3. That's a product property. And there's another example there with the square root of 18. And then you have a quotient property, right? Quotient meaning a divide. If you have the radical of a quotient, you can actually make that the quotient of two radicals. The square root of a over b is the square root of a over the square root of b. If it helps, right? If it helps you to do that, then you can simplify one part of it. Like the square root of 25 there, okay, I can simplify that. And this property goes both ways. So sometimes you have two radicals, and it actually serves your purpose to put them together into one radical, so you do that. So either way, product property, quotient property. Those are two things we got to remember how to do. And there's one other, which I know you've done before, and that is rationalizing denominators. The square root of 5 is an irrational number. What does it mean to be an irrational number? What do you think the prefix IR means? Not. Okay, so what's a rational number? What's the word that should jump into your head when you hear rational number? Fractions, right? So a rational number is any number that could be written in the form of a fraction. An irrational number is any number that can't be written in the form of a fraction. And the square root of 5 cannot be written as a fraction of integers, let's say, of an unsimplified fraction of integers. So we have to get it. We're not allowed to keep irrational numbers in the denominator, so we rationalize the denominator. And this is the standard practice, right? If you've got a square root of 5 in the denominator, then multiply by the square root of 5 divided by the square root of 5. Okay, what does the square root of 5 divided by the square root of 5 equal? It's 1, right? Anything divided by itself is 1. So really what we're doing here is we're multiplying times 1. And 1 times anything is the same thing anyways. So we're not changing the value, we're just changing what it looks like. Now, in the numerator, you've got the 1 times the square root of 5, which is the square root of 5. In the denominator, the square root of 5 times the square root of 5 is 5. So now we don't have an irrational number in the denominator anymore. So notice the pattern, right? What about if I had 1 over the square root of 3? What do you think that would look like with a rationalized denominator? It's the square root of 3 over 3. How about the square root of, or 1 over the square root of 17? The square root of 17 over 17. You know, I mean, you could take the step and actually multiply it by, you know, the square root of 17 over the square root of 17, but that's what's going to look like. It's not a mystery. I mean, do you remember doing this? When did you do that? What part of geometry did you have to do that? When you're talking about what? I will remind you, okay? $45, $45, $90. So remember the formulas? X root 2. So you would be given something like this, right? You would be given a 45, 45, 90 triangle. And you would be given one side length. Maybe the hypotenuse is a 5. And then you would have to solve for the others. Right? How would you do that? You would say x root 2 must be 5 because they're both on the hypotenuse. X root 2 equals 5. And then so you would solve for x, right? You would have to divide both sides by the square root of 2, so you would get 5 over the square root of 2. And then you rationalize the denominator to make 5 root 2 over 2. You know, and the same thing went for the 30, 60, 90, right? There you had x root 3. So I know you've done this before, but it needs to be like more of a common thing. So we understand what it means to rationalize the denominator. It means it's right away it's not rational, but you're going to make it rational. Okay, so let's simplify without using decimals. Okay, so we want to simplify this. So I'm going to tell you the way I do this is I think, is 80 a perfect square? No. Does it have any factors that are perfect squares? So how are you supposed to know? Well, you got to know your perfect squares, which again, you could, in your calculator, make a list of all the squares to check that out. This is something that I showed last year to even my Algebra 1, and it worked very well for them. In the calculator, and I've heard in my 1A class, kids who are bringing up stuff from middle school. Okay, I'm not going to do a factor tree, but if you want to do a factor tree, do a factor tree. I don't care, but I'm not going to do a factor tree. And I don't call the radical the house, okay? It's not the house. It's a radical. Okay, but if you've heard those before, then you know what I'm talking about. So let's say I wanted to find how can I simplify the square root of 80? In your calculator, and go to y equals, and on line 1, put x squared. Right? And on line 2, put 80 divided by x squared. Just like I've got it there. Okay. Then go to the table of values. And look in the column which says y1, those are all the perfect squares. So you got to go high enough to see, is 80 in that list? No. So it goes from 64 to 81. So 80 is not a perfect square. Okay, now go to the column y2. That's 80 divided by all the perfect squares. So starting as high or as low down the list as you can, start going up until you find one that goes in evenly, that you don't have a decimal. And which one is it? It looks like 5. 16 times 5. And the square root of 16 is 4. So the first column, it's 4 times the square root of 5. Right? So this equals the square root of 16 times the square root of 5, which is 4 times the square root of 5. And that'll always work. Just again, put on the first line x squared, put on the next line your number divided by x squared. So try to do it for yourself on those two. And you don't have to use my method, just whatever method you're going to use. See if you can come up with the simplified radical. So how did you split up 27? It's the square root of 9 times the square root of 3, which is 3 times the square root of 3. How about 98? Square root of 49 times the square root of 2, which is 7 root 2. So, I mean, you will, when we solve, not just now, right? This is the start of it. But when we get into, like, the next lesson and the next lesson, we will be doing square roots quite a bit. When we do quadratic formula, you use square roots. So you don't turn them into decimals. You have to simplify them as much as possible without turning them into decimals. Okay. So try to do that one. That's a solve, right? And notice on a problem, when you're eventually you're going to solve by taking square roots, you don't have to start with everything equals to 0, right? And this one is not. So what did you do to isolate? Divided by 4, right? So you had x squared equals 20. And then you took the square root of both sides. So now we've got x equals plus or minus the square root of 20. But how did you simplify the square root of 20? The square root of 4 times the square root of 5, right? So that is 2 times the square root of 5. Is it good? Not too hard? Okay, then move on. Try that one too. So everybody get that? 2 plus or minus 2 times the square root of 10. Okay, now this problem, it's not actually that b equals 0. Because z plus 3 squared, I mean, if I FOILed that, that would be z squared plus 6z plus 9. So it would definitely have a b. But because it's a perfect square trinomial, in fact, we can isolate the z. It's in the parentheses, one place. We really can solve this. So the only difference between what we did before, we're not isolating the z squared. Let's isolate the z plus 3 squared. Right, so isolate the squared term. So multiply times 5, multiply times 5. So now we've got z plus 3 equals 35. Oh, z plus 3 squared, sorry. Okay, then at that point, take the square root of both sides. Right? Right, so this is z plus 3 equals plus or minus the square root of 35. Okay, but you haven't solved for z yet. What do you have to do to finally isolate the z? You've got to take away the 3, right? Now when you do that, minus 3, this is the way it looks, right? You start with z equals, and then you say negative 3 plus or minus the square root of 35. The negative 3 goes in front of the plus or minus. Okay. All right. So let's try this one. This is another one we do together. So again, first thing, isolate the squared, right? Which is in this case x minus 2 squared. Then take the square root of both sides. So then I'm going to get x minus 2 equals, and I'm going to use the, well, okay, for right now I'll just say plus or minus the square root of 40 divided by 3. But then by the quotient property, I can say that's plus or minus the square root of 40 divided by the square root of 3. So now there's two things that we have to take care of. First, we have to simplify the square root of 40. And second, we got to get the irrational number out of the denominator. Right. Now, we just actually did the square root of 40. So what is that going to be? Yeah, so that'll be plus or minus 2 times the square root of 10 divided by the square root of 3. Okay, now how do I get rid of the square root of 3 in the denominator? Multiply by the square root of 3 over the square root of 3, right? Rationalize the denominator. Okay, I'm going to go down. So that'll be x minus 2 equals plus or minus 2 times, and I'm going to, what's the square root of 10 times the square root of 3? The square root of 30. And it's divided by 3. So we use quotient property, and then we use the product property, really twice. We used it to split up the square root of 40, and then we put together our square root of 10 and square root of 3. Okay, now we're not quite done. X equals, you got to add 2 to both sides. 2 plus or minus 2 times the square root of 30 divided by 3. Now, can I simplify that? Can I put the 3 into 30?
Yes.
No. Why not? You know, the 3 is outside the radical and the 30 is inside the radical, so they don't mix. So don't try to cancel something, you know, a denominator like that with what's in the radical. Okay. I think I only have one more slide. It's probably a you try. So you try to do that one. Okay. There's a common mistake that people are doing in this problem. If you divide by 3 first, you have to divide also the minus 1 by 3. You don't divide the first term in the 15 by 3 only. It's got to be divide everything by 3, which is going to leave a minus 1/3. Now you've got fractions, and you don't want to go there. So what would you have done? You should have added 1 and then divided by 3. I mean, just think, if this had been an equation like 3x minus 1 equals 15, what would you have done first? You would have added the 1, right? So you got to do the same thing here as you're trying to isolate the x plus 2. So that gives you 16 divided by 3. You take the square root, and I used a quotient property to split up the square root of 16 and the square root of 3. We know the square root of 16 is 4. And then you rationalize the denominator. It turns that 1 over the square root of 3 to the square root of 3 over 3. And then subtract 2 to the other side. Okay, so that's it. That's the homework. So you want to write this down. Write down the page number and write down the problem. So when you're done with the quiz, so when you're ready, take out a piece of paper, put everything else down, you just have paper, something to write with.